Hey, Ask a Pro community. We continue to interview our experts to suggest you a deeper dive into their background and adopt the tips they share at your company. Today, we'll gain insights into the practical applications and limitations of AI technologies like GPT-4, advice for non-technical people on implementing AI, and first-hand examples of AI's transformative impact on business and technology. Please meet Grigori, an AI developer who was working with large language models even before its popularity peaked, holds a doctorate degree in reinforcement learning in the field of drones, as far as I understood, and both improved existing software with AI and built AI apps from scratch. Hi.
Hello. Nice to talk with you today.
Thank you for making time, and you're very welcome. First question. It said on your profile that you are an AI developer. Could you please elaborate a little bit on what is it you do on a daily basis and how your typical process look like?
Sure. Basically, AI development, at least at my understanding, is the process of implementing the LLMs into some processes, where we can, for example, give that AI models or LLMs some tools, and they can do something more than just chatting with us. For example, they can create some code, saving files. They can go to some websites to check, let's say, weather in some city or country. They can check last news, and on the basis of it, they can get more context. They can get more actions. They can have even own memories, own databases, own like so-called track systems when we have a knowledge base for the LLM. They can also co-work with other AI agents, with other models, with like different abilities, with different prompts, with even totally different models. And when we can sum up all the models in together, we will make some AI system. It will work like very good, very best, like in my opinion much better, like at all. It will work much better than just using ChatGPT, and will have much more abilities.
Yeah, thank you very much. I got some clues. Hope viewers too. But so if we are talking about like the basic model, GPT-4, for instance, and your final result you want to get from it, right? What kind of transformations does it go through in brief, and what customization methods do you use, if I may call it that?
Mm, well, basically, in my work, if I'm working with GPT-4, like mostly yes, but there's different models. So basically, working with GPT-4 API, and from the level of Python program, usually I'm calling that, and well, getting some data from it, making some JSON response, for example, from which I receive in different fields I want. And well, the way of customizing, I don't know, you need to broaden your question to make it for me like better answer that.
Do you just keep calling it until you receive the result you want, so the response you expect,
Okay.
or do you feed it some new data? Like how is it
Uh,
all working?
it's well, it's a very complicated topic. I mean, there's a lot of different stuff we can do. It's like yes, there's some of examples when we can, if we're not satisfied with a result, we can pass that for example, another LLM that will check result of output of previous LLM, and if that checker LLM will not satisfied with this, it can recall it one more time and ask him, hey, you output bad result. Please do your task one more time. Even we
So,
can yes, even we can use some, for example, cheaper model like GPT 3.5 for like most of the task, and
Yeah.
but if that checker model is not satisfied with that result of that model in some particular task, it can call that more intelligent, for example, GPT-4 for Turbo. But yes, but there's only one of example how we can build that architecture of models. It's really a lot of possibilities, how we can combine them, what they can output, and yes, I can talk about it like very long.
This is what we're here for today. So is it if I understood correctly, do you connect them to each other for for a more advanced model to check the output of the least advanced, and therefore you um, optimize spend in this way, because the previous previous one was cheaper, like 3.5 API is cheaper than the 4 one. So uh, basically the more advanced model serves as a tutor or manager of the 3.5 model one, or
No, see, it was like just one of possible examples how we can do, but basically there could be some applications where, for most cases, for example, the GPT 3.5 will be totally enough. And if we can check it for like, and we will use it for optimizing costs and basically make all the process faster, but and we also need to implement some checking of output of this, or with some other LLM, or even with some, I don't know, JSON parser, for example, if that output will be JSON or something like that. It's basically much better if we able to implement some doing some stuff with programmatic way, some without implementing any additional LLM. It will be always better, more reliable, more cheaper and faster. So, and if we can check output of that model that way, and it will for some reason for some particular cases will not work, for that particular cases we can recall the model or use like more advanced model for that particular case, which will be some more complicated and standard. But for most of the cases, for pricing purposes, cost reduction purposes, we can use that cheaper GPT-3 and 3.5 model. Hope I
okay,
answered
thank
that
you.
question.
To start with, could you please explain some terms for our non-technical viewers, just like me? What is a large language model?
Well, large language model is the AI model. It's like a neural network or bunch of that network inside. Basically, all depends of the architecture of it, which basically generates text by predicting new words. So we given that some bunch of text, and on the base of it, it predicting new word with which it should continue the text. It has some probability distribution about, for example, for word cat it will be 40%, for word dog it will be 30%, and so on. And basically it will choose some most probable word, or will be that a probability distribution how to choose that next word. Also all depends on our parameters, how we set up the parameters. And yes, we have some sentence, and it should continue just that sentence, that text, and basically that's all. It's like nothing complicated in like
Nothing complicated, of course.
nothing complicated. Just
Not for you, at least. Yeah. Such a thing, yeah. Yeah, every kindergartner can understand. Yeah, in light of that, could you highlight its differences from the traditional machine learning, that you did in the past, as we discussed before? Um, yeah.
Sure,
So
sure.
what are the main differences?
But basically, that generative AI and that usual machine learning very often some kind mixed, and but in my opinion it's totally wrong way of thinking about it. Basically, generative AI is totally different field of study, not totally different, but very different. And there's totally we're thinking about different terms, about different applications. In classical machine learning, we basically want to train our model to make it perform something. But in generative AI, we mostly have already trained model, already ready for using it, and we need to to build all the application around that model. We need to prompt it appropriate way, and yes, that's mostly idea on it. Yes, there's some cases like fine tuning when we also need to train it. Not to train it from the beginning, but to like fine tune it, finish the training for our concrete application. So yes, but mostly it's not about it. It's mostly about like building all these things, all the tools around the models and make it optimal. Using the tools, make it like increasing the probability of good response from the model, because basically it's I think the main problem of that field, because from this main difference of AI development from traditional programming, because in traditional programming, when we write in some code, it always, when receiving A on the input, will output B on the output. But in with AI, it always some probability that it's some probability that will be good response. It's some probability that will be bad response. There's some probability that will be so response. And our task is basically to increase the probability of good responses, to increase quality of that responses, and maybe to make some safety features for that bad responses, to not pass them. Yes, so yes, but it's totally different as I said.